Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Suhada binti Zainal Abidin, metric number DE180175. For my part, I will present the result and discussion for case 1 and case 2, which is sudden large increment of load at bus 7 and sudden large decrement of load at bus 7. Okay, firstly, for the sudden large increment of load at bus 7, okay, this is the graph the simulation that we designed using MATLAB software. As we can see, there is two areas, which is area 1 and area 2. Then the sudden large increment is placed at the end of the circuit at area 1. The purpose of the load installation is to observe the ability of power system to remain in equilibrium after the load increase. Okay, firstly, for the graph, there we observe three graphs from here, which is rotor angle, rotor speed, and voltage of the system. From the graph of rotor angle, we can see that firstly, the system was unstable after the large increment, and then after 5 seconds, it starts to achieve the steady state condition. And then for the graph of rotor speed, the speed decreases in entire generator of the system. And the third graph, which is voltage graph, we can see that after the sudden large increment, the graph firstly rising and then it starts to achieve its steady state condition. It is because after 3 seconds, the circuit breakers detect the interruption in the system and operate to release the disturbance. Okay, and then we will see the graph for electrical power. Okay, this is the graph for electrical power. Based on the graph, the electrical power of the system suddenly rising, but then becomes stable after 3 seconds. It was suddenly increased because the load of the system increased. And then we will see the stability. Okay, based on the graph, the stability firstly rising when sudden increment was added, but then after 3 seconds, the circuit breaker operated and the system started to stable. Okay, that's all for sudden large increment of load at bus 7. Next, for the second case, which is sudden large decrement of load at bus 7, this is the simulation that we design using MATLAB software. There is also two areas, which is area 1 and area 2. For the system, the fault is set to start at 1 second and the circuit breaker used is normally closed. Besides that, 50% load decrement is placed at the system. Okay, firstly, for the result, there is also three graphs that we observe here, which is rotor angle graph, rotor speed graph, and voltage graph. From the rotor angle graph, the rotor angle of generator 1 and generator 2 was marginally unstable for about 5 seconds, while generator 3 is remain stable. Okay, next, based on the graph for rotor speed, the speed of the system is increasing, and then for the voltage, the a spike of generator 1 and generator 2 occurred and it reached steady state after 5 seconds. Okay, next, for electrical power of the system, from the graph it shows that the system had small increment but then slowly start to decrease. Okay, last but not least, for the stability of the system, Based on the graph, we can see that the stability of the system firstly increase and then it slowly start to decrease. So that's all for the sudden large decrement of load at bus 7. Thank you.
Okay, hi, Assalamualaikum. So today I would like to present about temporary voltage three-phase fault of bus 8. Okay, so before that, my name is Noda Nabi Sidik, DE180.50. Okay, so there is the model that I designed in MATLAB software. There's two of it, and area 1, area 2. So both of it we combine with the electrical circuit breaker in normally closed type. Okay, so at the below there's 4 load attached with the machine. Alright, so let's move to the machine and we look for the graph first. Alright, okay, so there is rotor angle, rotor speed, PU, and voltage graph. Alright, so for rotor angle there is first and second generator started at unstable mode and started to stable at second of 6, and then we move to rotor speed. Okay, so at the beginning the rotor speed started to increase and then they drop rapidly, and then they increase, and at a certain moment of time it's increasing slowly. Alright, so we move to PU graph, and then it started to, at the beginning they are unstable, and there's increment at the above of the graph, and then at the bottom of the graph so increment but the decrease mode, and then the unstable mode at between 2 and 4 seconds, and then they started to stable. Alright, so for the voltage there is unstable, so there's increment there, and then they started decreasing slowly, and at the second of 6 they started to stable. Alright, so next we move to machine signal. For the first one is electrical power. Alright, so this is the electrical power graph. So as we can see, there is instability of the system in form of electrical power. At the below of the graph there's increment, decreasing, and then suddenly increase, and then at the between 3 to 2 until 4 there is instability, and then they started to stable at moment of 6 seconds. So we move to stability of the system. Alright, so as we can see at the graph there's unstable, there is spark at the beginning, and then they decreasing slowly, and then this uprising there, and this increment at the above of the graph, and then they drop, and so at the second of 4 until 6 there is instability there, and at the moment of 6 they started to stable. So that's all from me. Thank you. Okay, hi, Assalamualaikum. So continue to case 6. Okay, so here as we can see, same as before, there is same model designed in MATLAB. So there's 2, area 1 and area 2, and combined with circuit breaker normally closed type, and then there's 4 load attached with the machine. Alright, so let's see the graph first. Alright, so here there's 4 graph. Alright, first is rotor angle, rotor speed, PU, and voltage. Alright, so at the first graph, which is first and second generator, seems like stable, and kind of really stable at second of 6, and then for third generator they're stable. Alright, so for rotor speed there's increasing at the beginning, and then they started to stable. Okay, so at PU graph, there's unstable at first, and then they started to stable at 2 seconds, and then stable until the end of the time. And we move to voltage, and there's rising at first, and then they dropping slowly. Right, so we move to electrical power. Okay, let's go. So here is electrical power. At the beginning there is rising, and there's increment there, and then started to stable at second of 6, and then they drop slowly. Alright, so next we move to stability of the system, and here at the beginning they're rising, and then they are unstable at the value of 0.15. Alright, and then they slowly decreasing until the end of the time. So that's all from me. Thank you. There's for case 6 and case 5.